Hi, this is our Watershed Walk Lab Day 2. Thanks for joining us. Let's have a look at what we have going on. We are going to be doing some water testing from our ecosystems today, so you want to make sure you have your aquatic ecosystem packet out. If you are absent from class, you want to check in with people from your table to make sure that you have the data from your ecosystem from the day that you were absent. All right, and so we're going to do some warm-up questions and move on. So a watershed is the area of, is it the area of land or the area of water? It is the area of land that all funnels into the same body of water. A watershed is the area of land that all funnels into the same body of water. If we have rainfall on Pickett Road right here by school, what happens to it? Well, it's just going to run off the road into a storm drain. So you have seen storm drains as the rain is heavy, you see the water going into those storm drains, and you know that as it picks up sediment and stuff, sometimes that water looks dirtier. So just keep that in mind. Then when we think about all of this, what happens to water that goes down a storm drain? Anything that goes down a storm drain just goes to the nearest waterway. So it'll go to the nearest creek or stream or something like that, and it will work its way to the nearest river. Okay. All of the water in Fairfax County that doesn't get absorbed into the ground is going to end up in the Chesapeake Bay. So even some of the stuff that gets absorbed into the ground will then still seep out through underground streams and things like that. All right, so lost my cursor. All right, we had a quick warm-up. What would you rather do question. So what are we going to do today? We're going to review key points that we've learned about watersheds, and we're going to evaluate Frost's section of this Chesapeake Bay watershed system. How? We're going to do that by observing and recording positive and negative impacts of Frost's grounds on the Chesapeake Bay watershed. So we're going to walk around the campus and just make some notes of new vocabulary and make sure that we understand our impact on the Chesapeake Bay watershed. Why are we doing this? It's so that we can see how the features of our school grounds have an effect on local waterways and then, of course, the Chesapeake Bay watershed system. All right, so last class we talked about this idea that if we put a marble in the top of this system, it might take different routes to get all the way down. Sometimes it's slower, sometimes it's faster, but it is going to end up down at the bottom. So when we think about our watershed, it's kind of the same idea. We have water that's going to drain down. Sometimes it'll drain into the soil first, but it is eventually going to head down to a lake or an ocean. All right. So, a watershed is an area of land that drains to a common body of water. So, any rain or snow or anything liquid is going to drain all downhill, pretty much basically. And it might go into streams and tributaries first. So sorry. Or it may go through the ground, or it may come straight into that lake or that ocean. All right, so which states do we know that have some land that drains into our Chesapeake Bay watershed system? Here's the Chesapeake Bay right here. So we have water that comes from New York, Pennsylvania, Delaware, and Maryland, Virginia, and West Virginia, and Washington, D.C. I think I hit everything. So New York, Pennsylvania, Maryland, Delaware, Virginia, West Virginia, and D.C. So all of those areas that are kind of shaded in blue there have water that will run off and eventually make it to the Chesapeake Bay. All right, so let's think about some things. When water lands on a paved surface, so this is a rainy street, right? Where does the water go? It actually runs along that paved surface until it can find a storm drain, or it might find its way to a field or something like that. So it's just going to not sink into that hard asphalt surface. It will come downhill until it eventually finds some sort of an egress, a storm drain or something like that. All right, so our water comes off of the roads and goes into storm drains. So looking at these pictures, what do you think has happened? that is just erosion. Okay, sometimes that might be a problem because if we have a lot of rain, the sediment here can get caught up in the waterways, and so it can kind of overwhelm the waterways. Also, you can see this might actually have an impact on the stability of this path or road or even fence situation up here. So we have to be careful about erosion. All right, what might decrease the amount of erosion? You may know this from other classes. When we have plants and trees that have a nice root system, those roots will actually help to keep the soil in place. They kind of hug the soil and keep it in place and keep it from eroding. So we're going to look at these surfaces. All right, so we are looking at two different types of surfaces here. You can see this is concrete or asphalt or some hard surface that's called impermeable. It's not going to allow water to drain through it. But this field with grass and soil is permeable. It does allow water to drain into it, and it will hold some water for at least a little bit of time. So again, the difference is this hard surface, water is going to hit this surface and it's going to just run off, generally to storm drains. But the water here, as long as it's not way too fast and too much all at once, the water here is going to sink into the grass and the soil, and it's going to be absorbed there. All right, so what's the difference here? Well, this is a storm drain. The water that comes in here comes straight off of the road, and it's not treated or anything. It just goes straight into this storm drain system, and then it continues on off into streams and rivers and eventually into the Chesapeake Bay. No treatment at all. A sewer is a set of pipes, though, that will lead to a water treatment facility. So for sewers, that's going to be water that comes from a house or a building that is water that we used for laundry or for dishwashers or for toilets, things like that. So the sewer water actually goes to a water treatment plant and it is treated eventually. Okay, storm water, storm drain, is just going to lead straight out into some body of water. But the sewer is going to go to a wastewater treatment plant so that it'll be cleaned up and it'll be healthier when it gets out into the bigger waterways. All right, so the water that does not soak into the ground, if it's just rushing along, and even over here, normally if we have water that lands on grass and soil, it's going to just slowly drain into the soil or absorb into the soil. This was too big of a rainstorm, and so the water actually overwhelmed the soil, and the leftover water that didn't get absorbed came straight to a storm drain. Here we have an overwhelming amount of water that has come rushing out, and it's going straight to a storm drain, and this is surface runoff, so this was probably near a parking lot or a road or something, and we have a lot of water that has rushed down and is, again, going to the storm drain. Okay, other things that can happen and get into water in storm drains and things, sediment from nearby homes or farms, or even if you think about frost, here we've got our renovations happening. So we have a lot of loose soil that might get caught into runoff water during a rainstorm. Sometimes trash and lawn debris, stuff that just ended up in people's lawns, gets carried into the river systems, into the stormwater drains. So sometimes it's grass clippings and branches and things, but sometimes it's litter. Right, and this says actually creek may contain raw sewage. So every once in a while you'll end up with something that allows bacteria to overpopulate. There's always going to be bacteria in rivers and streams and creeks, but sometimes you have potentially dangerous bacteria. Also oils that come from the bottom of cars and things that are driving around on the roadways. If they are dripping oil or antifreeze or anything like that, that's going to get caught up in water that's running off on the roads, and it's going straight into that storm drain. There are nutrients that can end up in the water too. A lot of times that'll come from fertilizer that we're using from keeping our grass green and lovely. And then again, just general trash and litter, things, receipts and things that have blown out of cars, or if people littered and left a trash bag or something, a McDonald's bag, that kind of stuff can get caught up in the water as well. So those are things that can get into your water runoff, and they can end up in the waterways. Here are two different storm drains, so think about what might be different about these two. This one's in the grass, and this one is directly running off from the road. So I'll give you the sneak preview. Water that's running through soil and grass, it's going to be filtered a little bit. So the storm water that's running into this storm drain is probably going to be filtered a little, and it'll be a little bit cleaner when it goes into this drain. This water that's running straight off of the road, it's not being filtered by anything. So any oils that are caught up in it, or any litter, or any nutrients, anything that's in that water is going to go straight into our storm drain. So water gets filtered by the roots of the grass or other plants before it drains into this storm system over here, this storm drain system. And a lot of times there's less runoff because some of the runoff is being absorbed by the ground. All right, so for class, it's a watershed walk lab that we're doing. So we will take a walk around the Frost campus. And so we walked out our front door and did a walk down by here's where we walk out. This is our classroom kind of under here. So we're going to walk down along here, and we're going to walk into the field just a little bit, come around the back part of the building, and work our way back up so that we can get back to the classroom. As we walk along that path, we'll have certain stops where we're going to discuss different aspects of our watershed and of where the water goes. All right, as we walk, please remember that one of our portrait of a graduate attributes is that we are going to be ethical and global citizens. And so a skill that we are going to work on today is that I understand that the choices I make have an impact on the health of the environment. And this is true of everyone in our area. All of our choices can have an impact on the health of our environment. All right, so everybody's going to get a page that you're going to fill in answers for as we walk around the campus. So you'll take a clipboard or a whiteboard or something so you have a hard surface and a pencil, and we're going to fill in information as we walk. Okay, we will stay together. You will listen while we're explaining things, and you will participate and record your observations. This is going to go in your binder, and this will be turned in when you turn in your whole packet. Okay, it's still academic time. It is not recess, so please remember, no horsing around. All right, after we've gone on our walk, we're going to come back, and we'll think about what are the positives from our Frost watershed. And so we can have some discussions about that. All right, so the rest of class is going to be dedicated to the new things in our ecosystems. So we've added fiddler crabs and black worms. All right, so both of these are animals. So we've added 2 new animals to our systems. We do still maybe have some guppies. Some of the ecosystems had guppies that didn't really survive, but we tried to replace some. So if you go into today's folder in Schoology, you're going to find information on fiddler crabs and on black worms. You do want to fill out as much as you can in your packet about those creatures. So you can do that once we have completed our jobs for today. Today's jobs, A is going to be temperature and clarity, B is dissolved oxygen, C is pH, and D is nitrite. If you are absent, make sure you get the data from somebody from your table. All right, so it is day 4 that we are testing, and in class we'll have a room temperature, and then once everybody does their testing, they're going to get quantitative data for all of the boxes. After everybody finishes, we want to think again, what changed from the last time, and what do we think might be the cause? What can we infer was the reason for that change? Okay. Finally, you want to make sure that you now have lots of organisms in your packet. You have Chlamydomonas, Spirogyra, Daphnia, Alodia, duckweed, pond snails, guppies, and you're adding today fiddler crabs and blackworms. So you want to make sure you have all of these boxes filled in. And then we have an exit ticket and we have a reflection, 2 different assignments. So this reflection is going to be homework. It's listed as an assignment in Schoology. You're going to pick 4 keywords that highlight what you learned today, and using all 4 of your words, and you can pick them from your sheet, your handout that you used when we did our walk around. You're going to write a brief summary of what you learned that might help someone who was absent, and be sure to use complete sentences. Okay, so just wanted to announce what that assignment was going to be. We do have an exit ticket, as we often do. Check your score. If you did not get full credit, try a second time. And that's a wrap. That's pretty much very quickly what we did in class for our Watershed Walk Day 2.